Hello Internet, I'm Guy. Welcome back. This is the fourth video in the construction of the InclinoClock, which is a collaborative project with my friend Dave Bruckenstein. I haven't ever actually met him in person. He lives in North Carolina and I'm in Maine. We're thousands of miles apart. But we collaborate by doing these wonderful CAD renderings that he does. So what we do is we have discussions about how the project is developing, and then we explore the options by using his CAD renderings to confirm what we have both come up with in our ideas and developments. So you'll see his drawings and renderings throughout. Believe it or not, he does these in Microsoft Word, which is mind-boggling to me, but that's his tool of preference. So today we're going to be making the front face, which is going to be constructed from acrylic, white acrylic, and brass. So stay with me, it's going to be a bumpy ride. So in order to mount this inclinometer into a piece of acrylic that's thicker than this, so I can embed it in a slot like this, I did a number of tests with 1/2" MDF, and I've managed to find the perfect radius after experimenting. This isn't the full depth yet, but it drops in there very nicely. So that's the plan for a 3/8" thick piece of white acrylic that I'm going to machine. So putting that aside for a moment, in my previous video I had a bolted down support plate made out of plywood, which is this one but cut down now, and I had it mounted to my rotary table, but for a moment there I lost control and it slipped. So what I've decided to do to prevent that from happening now is to put a couple of additional bolts into T-slots that I made. Oops, drop that right in there like that. So those will go in here, and then the central bolt will go in here, and that will secure this white acrylic so that it can't lose position relative to this. So let's get that bolted down and we'll get to cutting the outside radius of a white piece of acrylic. I've drilled all these holes in here because this will get covered with the brass. So once I've machined in this smiley face here, there will be another sheet of brass that will cover it up and hide the ends here of the smiley face where the inclinometer goes, so I can hide the glue that will secure it in there. So now I'm going to drop this on here using a large bolt down the center so that I can use this as a reference center for finding the center. Get this centered up again and tighten down, and I'm going to manually drop it in there and just see, oh, you know what, I still have the center from before. All right, I'm moving out to 5.25" from center, which will give me the 5" radius that I want, plus 0.25 inches here. But I'm actually going to go a little extra. I'm watching my DRO right now because I want to start a little further out and sneak up on that final cut. So I'm going to go, oh, right about there. All right. Oh, not looking good. I need more speed. Okay. Okay, so that was proving to be too much work to machine this down, so I went back to my standard practice for making acrylic circles, cutting it out on a bandsaw and sending it down to the line with my 4" wide by 48" belt sander. So this is going to be hidden underneath the brass, which will overhang very slightly by about 1/8 inch. So now I've got a clean edge here. The other thing I need to do is put 2 mounting holes in here. This is 7/64. It's just going to drop right in there to screw that down to the faceplate that will is attached to the motor that I made in an earlier video. The inclinometer here is just under 5/16, so I'm going to use a 2-flute 5/16 cutter and then cut this smiley face in here. So I'm now going to take a pencil mark and indicate my starting position and roughly my ending position here. I can always go over, that doesn't matter because this can just sit right in there. Then of course I'm going to cut the brass to sit on top, and I'll make a prescribed distance that will be somewhat less than the ends here to cover the glue on the ends to hold this in. So this is the scary part. The commitment cut is what I call it. I'm going to be cutting all the way through in probably around 1/8" depth of cuts first. So let's see, get this set up. I'm going to run it at maximum speed, 2200 RPM. and lowering into the cut, about 1/8 of an inch. Lock that down, and now start crawling through the cut very slowly. Cleared off that dust, and okay, well, it fits well, but I didn't cut far enough, so I'm going to make another mark there. Grab my pencil, and I need to cut to about there, because that's going to fit just right up against that line. All right, so I'm going to complete that cut and then work my way down. Okay, second sanity check here, just to make sure. I've machined this out further, and it looks like it's going to sit in there just fine. There's a small chance I'll have to make a second, slightly larger radius pass to make sure it drops all the way through. I'm only 1/3 of the way through, so continuing on. Clean up pass. All right, let's vacuum that up and see how it looks. Okay, final sanity check. Does the inclinometer fit in there? Did I get my radius perfect? And oh yes, that is absolutely perfect. So I can just glue it in at each end in the final assembly, and this is going to be just fine. That was nerve-wracking. This is the brass sheet here, which is fairly thin, and of course I have a 16 TPI blade, which is less than optimal. I'd rather have a metal cutting blade on my wood cutting bandsaw. But I did do a test cut right here, and it cut really nicely. So I'm going to cut this slightly oversized, and then as I normally do, I'm going to go on my belt sander and sand it down to a line here. That looks pretty good. Okay, over to the belt sander. All right, I've got 220 sandpaper in here, which is just enough to sand this down nicely, I hope. Let's see how it plays out. So I've been test fitting this over and over again to make sure that this centers on the pin here in the middle of the clock, which is going to drive it around. So that drops on there, and I've got clearance just barely all the way around. That's all I need. So I'm going to mount this onto a piece of wood on my wood lathe and then hold up some Scotch-Brite. Okay, so it's on the wood lathe, and it's centered on this bolt that is now in my chuck there. So the next thing I'm going to do is spin it up real slow and just sand off some of the roughness on that corner there. Take off some of the filings and shavings. Just clean it up a little bit so it doesn't nip my fingers. And then I'm going to start with the green Scotch-Brite and see if I can start making these, yes, that kind of thing right there. That's the look that we want. That beautiful, almost like a record, a vinyl record. I think I'm going to go a little bit faster. Yep, I was a little nervous doing this, but it looks like it's going to work out. Well, here goes the moment of truth, to mill through this brass to create the slot that will be the viewing slot through which you'll be able to see the inclinometer. So, here we go. Ah, there was... Okay, I'm going to have to clear out that little piece that fell in there. There we go. All right, hopefully now I'm going to be more stable. That was a little nerve-wracking. Yep, I've got a bit of a wobble in that cut for sure, but it is what it is. That's the clearance height. Okay, I'm going to stop there and remove all the shavings and then do another spring pass back the other direction. Okay, this is like removing the bandages from the patient. Oh, it's a little torn up around the edges. I think I can clean that up by scraping it very carefully. I'm leaving tape marks here, so I'm definitely going to have to re-lacquer the whole thing. Yeah, I can probably sand those marks out, hopefully, and then I'll definitely have to re-lacquer everything. I've done a bunch of tests with different drill bits, and I found that a 120-degree spotting drill bit will drop through the brass really nicely here. So I tried other drill bits and they would either grab or not make a nice hole. So, okay, this is what we're going to do. Didn't like the sound of that, but this is all locked down as good as it's going to get. So now I'm going to move to the next position here. And carry on. Test assembly time. So the acrylic plate goes on first. These two screws go into these two holes right here. So I'm going to lay this on there first, and it'll index onto this pin like that, and then eventually these screws will drop in there. I'm not going to do that right now, and that will secure the acrylic to the motor. Then I'm going to put the brass on here like that, roughly, and the little nubbin that will go on there that will center the brass onto the acrylic. So now we can see the white dots here. This will drop in there eventually behind the brass and hidden in there. What I need to do now is put some white acrylic in the back of that as a reflective surface so you can easily see the inclinometer. So that's my next step, just to cut this little smiley face piece of acrylic to go on the back. Off camera, I cut out this piece of translucent acrylic that's going to go on the back. Dave and I decided to use a translucent plastic here so that we can shine some light through it, just in case when this is embedded in there it's less visible. So we'll find out after we've done some tests here. So I'm going to use some Weldon 4 acrylic bonding agent, which actually technically welds acrylic. So I'm taking a little shot of it out of here. Going to put it in my needle dispenser. Just drain that out. This stuff is really, really, really toxic, so you have to be super careful with this. Close that up, seal it tight. So now I put the lid on here, and I have a little syringe dispenser now, so I'm going to locate this exactly where it needs to be to cover that whole slot. And now I'm going to shoot acrylic down into there, and that will weld this whole sheet onto the back. So this sets very quickly. I can still feel it moving, so it's going to be a few more seconds, but it should be done in... This is pretty old, so this I actually dated 1/20/20, so it gets old and it takes longer to set. Okay, so then the idea is that this will just drop right in there with a little bit of wiggle room there so that we can put a little dollop of probably silicone adhesive in there to glue it in. And then, of course, the brass will go right on top of it there. And this will drop in, and that's what we're looking at. Getting close. I've mounted the brass back on the wood lathe with the same piece of backing that I had before, and you can see there's some dings and scratches that happened, and also the blue tape has affected the surface here. So I'm going to do an experiment using some alcohol first, because shellac is alcohol based. So I've got this soaked in alcohol. I'm going to spin it up a little bit and just see if I can smooth it out by very lightly brushing it with alcohol to smooth all of the shellac out a little bit. You have to be very careful. You see now, oh yeah, that might or might not work. Let's see what's happening here. Yeah, might have to apply some more shellac here. Let me spin dry it first. The thing about working with shellac is you can overdo it. Oh my goodness. Oh. I may have to go in and sand all this back off again. This is not looking good. Well, that's better. After brushing alcohol on here and then wiping off the shellac, I've got it down to the basic brass, but there's an interesting marking here from the way that the spinning is interacting here. But now I'm going to take a shot at spraying and brushing more shellac on there and see if that's going to work. All right, my brush is lightly soaked in alcohol, and I'm going to spray shellac right onto the brush. Let's do a quick test. All right. Let's see if that's going to settle out. It's going to take a while to dry, and you'll see it go milky first, and then it should clear out. You see the milkiness showing up in here? I'm hoping that's a good sign. Well, maybe the whole thing isn't going to go milky. Maybe I just got that in one shot. I want to leave it spinning to let the air dry on it. I'm really tempted to stop right now and have a look. Boy, that looks perfect. All right, I'm going to stop. Ooh. It looks like I kind of nailed it. Okay, I'm ready to glue the inclinometer into the slot, but before I do, I just wanted to flip it over and show you that I've glued a magnet on the back here that will interact with a magnetic sensing reed switch in the base of the clock so that the stepper motor can come around and find an index or home reference. Stepper motors are always measuring or moving relative to a fixed position, and so this will help the stepper find a fixed position, and then it'll know how to move to the clock positions that it needs to. So I'm going to use a brand new container of E6000, otherwise known as goop, very good adhesive, and just shoot a bunch of it in there. And another bunch right in there. Let that settle in. So that's it for this video. Thanks for sticking with me through this whole process. There's at least one more video, probably two more involved before I'm finished. If you've enjoyed this so far and you haven't subscribed, please do so, and you can click the notification bell so you'll know when the next video comes out in about a week. And please give me a like and a super thanks if you'd like, so that I can get a little support. And also there's a link below for Patreon support too, so I could use any support you're willing to give me. Thank you. In a little bit of a heads up here, in the next video, what I'm going to be doing is making the back panel here that will cover the electronics. I'm going to also finalize some details of the electronics by adding a power jack and a set hour button and so forth. So stay with me for that one. Hope to see you soon.